Hi everybody. So the other day we talked about standard form. The standard form of an equation, if you remember, is ax plus by equals c. And today we're going to look at a real life problem that's going to be graphed in this form. So Steve burns 10 calories per minute. Please add in the word biking. And swimming laps burns 12 calories per minute. Let x represent the number of minutes that Stephen bikes and y represent the number of minutes that Stephen swims laps. So these are let statements that are given to you. X is the number of minutes that Stephen bikes and y is the number of minutes that Stephen swims laps. Write an equation in standard form that relates the times that Stephen could bike and swim laps in order to burn a total of 300 calories. So we have a total of 300. Right? We looked at these equations the other day. We know that he's going to burn 12 calories per minute biking, but we don't know how many minutes he's going to bike. That's X. We know that he's going to burn, 10 calories per minute biking. Let me fix that. And then 12 calories per minute swimming times y minutes swimming. There's your equation in standard form. Now we're going to graph these on the x and y axis in a real life situation, but we're not going to use slope this time. It's going to be much easier to graph using x and y intercepts like we learned the other day. So to find the x-intercept of a line, remember you plug in y to be 0. So I'm going to set up 10x plus 12 times 0 equals 300. 12 times 0 is 0, so that goes away. 10x equals 300. This tells me that my x-intercept is going to be at 30. So when I graph this, on my x-axis here, I need an x-intercept of 30. So maybe I'll count by, I'll make every 4 squares. So this is 0. I'm going to make every 4 squares represent 10. So this will be 10. 1, 2, 3, 4, 20, and then 1, 2, 3, 4, 30. And this will be my x-intercept at 30. And then this is x is the number of minutes that he bikes. So I'm going to label that also, number of minutes biking. My y-intercept, I'm going to plug in the opposite variable to be 0. My y-intercept, I'm going to plug in x to be 0. So I'm going to sub in 10 times 0 plus 12y equals 300. So this is going to drop out, and I'm going to have 12y equals 300 divided by 12. My y-intercept is going to be at 25. So for my y-intercept at 25, I will do every 2 squares is 5. So I'm going to go 5, 10, 15, 20, right? 2, 4, 6, 8, and then 25. So my y-intercept is here at 25. I could have made a better scale and stretched this out a little bit more, but there's my line. I do not have to graph. I don't know how to use the ruler on this function, sorry. I do not have to figure out my slope. That's what makes this really easy when it's in standard form and it's a real life problem. And I'm going to label the equation here 10x plus 12y equals 300. I'm going to label my axis. My y-axis is the number of minutes swimming. And that's it. Okay. You have one problem to complete like this on your homework. It's about the number of calories from protein, I think, or the amount of grams of protein from different foods. Okay, so you're going to do a very similar thing. You're going to set up x-intercept, y-intercept, find those two, plot the points, and connect, and that's your line. You do not need to worry about slope for this, just x-intercept and y-intercept. It makes it faster. In addition, you have another worksheet on practicing the older method of graphing, which is using slope and y-intercept. So for those, you have to then think about rise over run. Positive slopes go to the right, negative slopes go to the left, and graph. And just, you know, we're practicing both types of graphing methods. Okay, thank you. I'll see you guys soon.